Hi everyone, welcome to the 6th grade science week 2 lesson. Now this is for the week of April 13th. My name is Jenny Brown and I teach 6th grade science at Bearden Middle School. If you need the handout for this video, it can be found electronically on the KCS website underneath the Student Resources tab. Now if you need a printed copy, they can be found at the mill distribution sites on Monday 10 a.m. to 12. So what are we going to be talking about today? We're going to be looking at two different standards. The first one is construct a scientific explanation of the transformation between potential and kinetic energy. And the second one is going to be to design and test different solutions that impact energy transfer. What is energy is our first question that we're going to be looking at. How can energy transfer from one form to another? And finally, how can you use the engineering design process to create a device to show energy transfer? So first you need to understand what is energy. Energy is the ability to do work, and energy can be found all around you. Here are some examples. We've got a basketball falling, we've got a person, so energy is inside of you. We've got the sun, an atom, we've got a light bulb, we've got a battery bouncing on a trampoline, or the trampoline itself is energy. And then we've got sound. And there are two main types of energy. There's going to be potential energy and kinetic energy. So let's take a look at potential energy. Now, it's stored energy due to the position, shape, or condition of the object. And today we're going to be looking at just kind of a general potential energy, but if you're not already aware, there are specific types of potential energy. There's gravitational potential, where we have the basketball falling. There's elastic potential, where we are jumping on like a trampoline or stretching a rubber band. Then there's chemical energy that you find inside of food, and you actually have it inside of you. And then there's nuclear energy, like from the sun. Now, one of the main concepts that you need to understand about potential energy is that you can increase potential energy by increasing the height of an object or increasing the mass of an object. So if we look at the far picture to the right, we can see that the ball on top of the stairs at the top has more potential energy than the ball at the bottom of the stairs that has less potential energy. Now, kinetic energy. It's the energy of an object due to its motion. So kinetic energy is something that is in motion or using that energy. Some of the main types of kinetic energy are going to be sound, electrical, light, mechanical, and thermal. Now if you remember, thermal is radiation, conduction, convection. Those are all different types of heat transfer. So if you remember that lesson, you can start to sort of put that idea with the different types of kinetic energy too. Let's look at the far picture on the right of the screen. We have the red car. It's like a larger car. It's an SUV. Notice it's going 30 miles per second, so it's going faster than the motorcycle and the light blue car. That means that the SUV, the red car, is going to have more kinetic energy, not only because it's larger, but also because it's faster. And then the blue car is going to have more kinetic energy. Even though it's going the same speed as the motorcycle, it's going to have more kinetic energy because it's a larger vehicle. Now, how can energy transfer from one kind to another, so one form to another? One of the most important concepts that you need to understand about energy transfer is the law of conservation of energy. Now, it states that energy cannot be destroyed or created. It only changes forms, so from one kind to another. So, for example, from potential to kinetic. So take the picture there on the left. We've got a tennis ball being dropped. Okay, so you hold the tennis ball up, or you hold anything up, it's going to be increasing the potential energy as you bring it higher. And when you release it, it's going to be decreasing in potential energy because it's no longer as high, but it's going to be changing that energy over into kinetic energy. So it's taking it from potential energy and to kinetic energy as it's moving. So how can energy transfer from one form to another? Energy transfer is just the energy changing from one form to another. We have two examples here. The first is a roller coaster, and the second is going to be like a swinging pendulum. It's changing potential energy back to kinetic, it's changing potential energy to kinetic and then back to potential. So let's look at the roller coaster first. Notice the roller coaster, that first box, the roller coaster is sitting at the very top of the hill. It's not going to be moving, so imagine you went up on a roller coaster, you're sitting at the top of it, right before you go down and it gets your stomach. So you're sitting at the top of that. You're going to have the most potential energy there because you're at the highest part of the roller coaster. You're not going to have any kinetic energy there. Now, as you start to go down the hill, it's going to be decreasing in potential energy but it's going to be increasing in kinetic energy. So the faster it goes, the more kinetic energy it's going to have. Now let's look at our pendulum. In box A, notice the position of the pendulum. Imagine you've pulled it all the way back and you're holding it there. Right before you release it, it's going to have the most amount of potential energy. It's the highest it's going to go. Then box B, when you're letting it go, it's at the bottom of its swing, it's moving its fastest. So it's going to have the maximum amount of kinetic energy there. Then that ball continues to go up right before it drops back down. So imagine you're on a playground and you're swinging back and forth and you go back. Right before you drop back down, you've increased your potential energy. You have maximum potential energy again. Then when you drop back down, the faster you go, the more kinetic energy you're going to have. So if we know that the law of conservation of energy says that energy can't be destroyed, why does a pendulum stop? That's because it's not just going from the generic potential to kinetic back to potential. There's actually other forms of kinetic energy that the potential energy is turning into. So remember that thermal energy and sound energy I mentioned before? Imagine that pendulum swinging back and forth. It's creating friction, and friction is a way to get thermal energy. So imagine, put your hands together, and you rub really, really, really fast, and you feel your hands heat up. That's thermal energy. So anytime you have an energy going from one kind to another, so for example, potential to kinetic, we're going to have thermal energy being released as well. That's why the pendulum stops. Another example could be sound. Maybe that pendulum going back and forth, you can hear it. Maybe it's making a clicking sound or noise as it moves back and forth. All right, so let's do a quick recap and then we'll get into our activity. Question number 1. Potential energy of a basketball is greatest when it is falling, rolling along the ground, about to fall, or D, rising. Take a second, think about it, look at our keywords. Potential energy is greatest. It's going to be C, when it is about to fall. It's at its highest point, but it isn't falling yet. Question number 2. The kinetic energy of a pendulum is greatest at the bottom of its swing because the pendulum is A, at its greatest speed, B, about to swing upward, C, at its lowest point, or D, at its slowest speed. So why is the kinetic energy the greatest at the bottom of its swing? So go back to that picture we looked at about the pendulum. It is A. It's at its greatest speed. It's going the fastest. Question number 3. A change of energy from one form to another is called A, energy transformation, B, energy conversion, C, kinetic energy, or D, potential energy. A, energy transformation. How are you doing so far? We've got 2 more. Question 4. What does the law of conservation of energy state? It states that energy cannot be created or destroyed. It only changes forms. All right, last question. Question 5. How much potential energy and kinetic energy would be at each stop? So let's look at our first box here. Remember, the roller coaster is at its top of the hill. It hasn't gone down yet. So if we can remember that, it's going to have the maximum amount of potential energy. So it's all potential, no kinetic. Now let's look at our second box. The roller coaster is halfway down the hill. It's starting to convert that potential energy into kinetic, so it's going to have half potential and half kinetic. All right, for our last one, the roller coaster has reached the bottom of the hill. It's going as fast as it can. It's going to have maximum amount of kinetic energy. Good job, guys. All right, let's get into our activity. All right, our problem, need, or challenge is going to be to design and build a Rube Goldberg machine using the engineering design process to complete a task that has at least 4 energy transfers using materials that you have in your home. So you need to understand what the engineering design process is. It's a series of steps used to solve problems. Engineers use this all the time. They build bridges, clothing, buildings, electronics, machines, pretty much everything. Engineers go through this process to build and to solve problems. The first step is going to be ask. They have to identify a need or a problem. So you see our problem above. Then we are going to have to plan. We've got to come up with some possible solutions, design it, draw it. Then we're going to be able to build, test our machine, and then we're going to be able to improve it, make it better. So what is a Rube Goldberg machine? Rube Goldberg is a cartoonist that's famous for taking a very simple task and making it extremely complicated. Now we can use his extremely complicated machines to show how energy is transferred from one kind of energy to another. You can see the example below. So let's begin. Part 1 is to ask. Now you can follow along in the packet, or you can just write this down on a sheet of paper. It's whatever is easiest for you. Number 1, what is the simple task that you're going to make complicated? We need to figure out what you want your machine to do. Number 2, what chain reactions do you want your machine to do to show energy transfer? So what are you going to have happen in your machine? And number 3, where can you build this without it being a giant mess in someone's way? So for example, number 1, I'm going to make something that can help spray some cleaning solution. I've been cleaning a lot, so it'd be a whole lot easier if I had a machine to do the work for me. So I want something to squeeze the handle, maybe hold up some paper towel, and maybe have maybe some kind of tube that drops a marble that would allow the spray bottle to spray. So I can just build this, number 3, I can just build this on my kitchen counter. It won't be in anybody's way. Part 2, plan. Now here you need to make a list of all your ideas. So you can kind of think about, you don't have to write any or draw it out yet, but kind of think about what do you want to have happen in your machine. You can use anything in your house as far as materials go. Make sure you have permission, and please don't use anything that's breakable or flammable. Examples of materials that you could use are dominoes, paper tubes, string, marbles, egg cartons. You can use any kind of cardboard, rubber bands, books, straws, bouncy balls. You've got a lot of options here. Just again, make sure you have permission. What I'm going to use for my machine is a tube, marbles, string, a ribbon core like a thread spool, spray bottle, napkin, clothespin, and a cleaning solution. Now the second part of part 2, so we have to plan it out, is going to be to actually draw the idea out. And we're going to draw it, label it, and make sure that you number your chain reactions in the order that they are going to occur. So you can see here I have all of my items labeled as what they are. I've got my chain reactions labeled as well. So my red numbers there indicate what I want to happen. I want the marble to roll down the paper tube. I want it to land in the tray. I want it to pull the string that's going to pull the spray bottle handle, and then that will spray the paper towel. Then I'm going to build it. Now for building, you need to make sure that you keep these 4 things in mind. Number 1, you need to be able to explain at least 4 of your energy transfers. If we go back to our original problem, it asks for you to have 4 energy transfers, so make sure that's in your design. How does your machine demonstrate the law of conservation of energy? Number 3, in what ways are you transforming potential energy into kinetic energy and then back to potential? And then number 4, what types of energy can be seen? Gravitational potential, elastic potential, chemical potential, light, sound, electrical, mechanical, or thermal. Part 4, we're into testing. Now, test your machine at least 3 times. We don't want to make any changes yet. We want to see what's working and what's not working, and we're going to record the results in this table below. So for example, what happened each time that you tried your machine? What needs to change? What could you do to make it better? So for example, the marble is shooting over the landing spot so the tray is not dropping. In step 5, we improve it. And this is one of my favorite parts of the engineering design process, is that you get to take a look at what you've already done and make it better. You may have even done that as you were building when you just realized that something didn't work the way that you wanted it to work. You may have went ahead and improved it then. And if you did, that's okay. Now's the time to make it even better. So once you know the improvements that need to be made, you've already started the design process already over again. So below or in your packet, you can draw or explain the modifications that you've made. Now, for example, I've changed the angle of the tube so the marble's actually going to land on the tray instead of shooting over. I've made the tray holding the marbles even larger, so in that way it wouldn't shoot off. Now you can repeat steps 4 and 5 as many times as you want. Now let's take some time to reflect. We've got a few questions to make sure that you understand the activity that you did today. Number 1, what energy transformations were taking place in your machine? Number 2, explain how you went through the steps of the design cycle again after finding ways to improve your design. Number 3, what would you do differently if you had an unlimited supplies to create a new machine? Number 4, what did you learn about energy and energy transformations while completing this activity? Number 5, if you could build another Rube Goldberg machine to complete a daily task, what would you want to create and why? Alright, so that is the end of our activity for today for 6th grade science week 2. I hope this video found you safe and healthy. Now if you need the packet that accompanies this video, remember it can be found on the KCS website underneath the Student Resources tab. And if you need the printed copies, they're available at the mill distribution sites on Monday from 10 to 12. Bye guys!